tall person? Okay, here we go. Hello, everybody. My name is Margaret, and I'm here with Lighting Charge Solutions. And I'm an entrepreneur lead, and there's also in the room two of my academic leads, Tom Schmedeke and Michael Walter. So if you have further questions, we'll be upstairs with a table and showcase. So you're more than welcome to come up and ask us some questions. So if you haven't heard enough about electronics, here's some more. What we're working on is electron hole transport materials for applications in organic electronics, such as organic lighting and diodes and solar cells. And particularly, we're focused on improving the lifetimes of these devices, increasing their efficiency, and lowering production cost of these materials. Throughout the Ventureprise launch program, in 6 weeks, we completed 70 interviews. And here's what we figured out. So we decided to explore things beyond the United States. So we talked to several countries, as well as multiple types of companies, such as large companies, startups, academic researchers, small companies, big corporations. So we decided to kind of go big and see what's going on, because we didn't have a lot of clue about the actual scale of this market. So what did we do? We talked to leaders in organic lighting and diode industry, as well as solar cell industry, and see whether the market existed at all, as well as we talked to developers of these materials to see, well, who's working on what and what is going on in the market. We also talked to policymakers, as well as possible competitors that are selling these materials, and see whether we can compete with them or not. So what is the problems that we found that could be opportunities? So some of the problems are the matching of electron hole transport materials in these electronic devices, which specifically we need a larger library of the lower cost materials, as well as they need to be customizable, as well as they should be easily handled. And there's a huge problem of the delivery turnaround time. There's usually about 3 to 6 month wait time on these materials, and the companies would like it to be under 1 month. So our aha moments were the fact that the market does exist, and it's actually greater than we thought. And the timing is great. People are mostly right now focused on the emissive materials, and they're just now starting to look at alternatives for electron hole transport materials. So we could easily hop on this train and go on with further development of materials, as well as the sales and production. And our customer segments could be displays, lighting, application type companies, as well as academic researchers. So what we're offering as our values is lowering the cost of the product, the final product, which will improve the sales, and as well as improve device efficiency and lifetime, which will improve the revenue because more people would start buying these devices. And our customer segments we settled right now at academic researchers, display corporations, and lighting companies. As far as the market size, here's an example of the market for electron transport materials. It's about $1 billion market, and reasonably we could handle about 100 million of that market and actually kind of step our foot into it. So realistically, we could, if we start right now making these materials, by about 2022, we could make that market of 100 million a year. As far as what is next, we're currently in the process of finishing our patent, as well as we're seeking funding to start pilot studies and get organized in the labs and start producing these materials, possibly going to the National I-Core program, as well as after that, if we get the funding, we'll start the production and submit for the next round of SBR, STTR rounds, or other investment type applications, and then hopefully by fall of 2020, we could start actually making a revenue. And with that, I would like to thank you for your attention. My name is Margaret. I'm with Light and Charge Solutions, and I would like to see you upstairs at the table. Thank you.